Everyone, welcome to our webinar, Building Native Cross-Platform Apps with Xamarin 4. I'm Courtney Whitmer, Marketing Manager at Xamarin, and today you'll be hearing from Xamarin developer evangelist James Montemagno, who has been developing with the Xamarin platform for over 4 years. He's been a .NET developer for over a decade, working in a wide range of industries, and was a professional mobile developer before joining Xamarin. Now here's James.
Awesome. Thank you so much, Courtney. So I'm super excited to be here today to go over the entire Xamarin platform, building and crafting native iOS, Android, and Windows applications, all in C# and in .NET, and showing and highlighting some of the brand new features that we just announced and released as part of Xamarin 4. So let's get into it. Now, Xamarin's mission's always been the same, is to make it fast, easy, and fun to create great mobile apps. And we do that by allowing you to build all of your mobile apps all in C# and share code across all of your platforms and build out great native applications with native API access. Now, today we're going to focus heavily on the Xamarin platform, but Xamarin, we're your complete mobile solution. Because as you know, it's not just about building your application, it's about also testing and monitoring your application to ensure high quality, but also to get errors and reports back from your users. So as your complete mobile solution, of course, you can do all of your testing of your business logic with, NUnit or XUnit per se, but how do you ensure that your application is scaling and acting correctly on the tens of thousands of devices between iOS and Android that are out on the market? That's how we have Xamarin UI Test and the Xamarin Test Cloud with over 2,000 unique iOS and Android devices. With Xamarin UI Test, it's an automation framework to do automated UI scripting to tap, poke, enter text, rotate, do all the things that your users are going to do. And then you can take those tests and run them for free on a simulator or a local device or ship them to the test cloud and test them on thousands of physical devices to ensure as you're fixing bugs or adding new features, your workflow of your application doesn't break. But what happens after you ship your app to the App Store? How do you get crash reports back or some analytics from your users? Well, that's where Xamarin Insights comes in. With just a single line of code, you get full managed and native crash reports for any of your iOS, Android, or Windows applications. Then, of course, you can report, track, and identify your users with simple cross-platform API. And, of course, we have the best places to learn all of Xamarin, not only with great webinars like you're on right now, but, of course, our documentation at developer.xamarin.com and all of our samples, and, of course, Xamarin University, which is live interactive training to accelerate your mobile development, to get you started with just C# or F# or Android or iOS and Xamarin Forms, all the way to a certified Xamarin developer. Now, today, I'm going to focus heavily, again, like I said, on the Xamarin platform, the building part of it. And if you're brand new to Xamarin, in this webinar, we're going to go over the entire Xamarin platform, build some apps with the traditional approach in Xamarin Forms. Then we're going to dive into the actual new stuff that we're going to see as part of Xamarin 4. Cool. So our approach to mobile development is extremely unique. We enable you as a C# .NET developer to build a shared C# mobile backend for all of your applications. This is all your business logic, your data models, view models, RESTful service calls, SQL databases, things that are going to be common across all of your mobile applications. Then we give you the tools to build out and craft a beautiful native user interface for iOS, Android, and of course Windows. Not only are we enabling you to share this C# code base across all of them, but your apps are 100% fully native with native API access and full native performance. Now, if you're brand new and you might be wondering how this works, well, think of it kind of from the Windows side of things. As a Windows developer, I've been a Windows developer for over a decade before moving into iOS and Android. Essentially, we have the .NET libraries, this amazing library of just goodness. So it's everything that's running here on the .NET runtime. So our favorite libraries like System Link, XML, Windows Data, Numerics, things that we kind of know and love as C# developers. Then if we want to target, let's say, phone or store or Windows 10 or even a WPF application, we download an SDK and we get some new APIs to mess around with. So whether I want to interact with a phone or the store desktop application, these are specific SDKs and libraries to interact with that hardware or the user interface. Now you can think of it the same when you choose Xamarin to go to iOS or Android. On the bottom here for iOS, we have all of that .NET goodness. This is your library. This is your shared code. But all this is running on the Mono runtime, which is the original open source implementation of .NET, and we create and we maintain. But what we do, what's extremely unique, is not only share all that .NET goodness on the bottom between all of your applications, but up top you get 100% API access to every single API in iOS and Android. So if you want to do something, you can. If you want to do iBeacon, UIKit, MapKit, Core Graphics, Core Motion, and it's just a subset of everything available, you have access to all of those. And we don't stop there because these just aren't wrappers around the APIs. Essentially, these are C# bindings to all these APIs, and we add C# features like async await, lambdas, link, events, delegates, things that we know. So even though we're accessing that native API in iOS, it feels natural because it's the proper C# idioms and syntax. And of course, we do the same thing for Android. You have all that .NET goodness on the bottom, and of course, the Android APIs on top. We give you full native performance in multiple ways. We do a full ahead-of-time compilation on iOS. Essentially take your C#, compile it down into IL, and one more time into LLVM bytecode, run that puppy right through an LLVM compiler and optimizer, and boom, native ARM binary running natively on an iPhone or iPad or any iOS device. And over on Android, we do have an ahead-of-time compilation, but most Android applications leverage just-in-time compilation, which enables you essentially to run the Mono runtime side by side the ART or Dalvik, which is the standard Android runtime. So we're able to run and execute your .NET code over on the Mono side, and then JNI across to your to that ART or Dalvik for your Android-specific calls. Now, what's amazing here is that you're getting native speed, native performance, and to your users that are downloading, it's just another app from the App Store. There's nothing different. They go to the App Store or Google Play, hit download, nothing else to install or anything like that. It's just an app just like you would expect. So what you get at the end of the day is a .app or a .apk file that you'd be delivering to the App Store or to Google Play or distributing in-house if you're doing ad hoc development. And of course, with Xamarin, we're always up to date. So as the latest and greatest features are coming out, we're there for you. So you never have to worry about not being able to access a new feature. We've been shipping same-day support for iOS since iOS 5. We just released iOS 9.2, which is the latest and latest that just came out. And it's really important for iOS because iOS users, they update quickly. You know, when iOS 9 came out, for instance, 50 to 60 or 70% of all users upgraded within just the first few weeks. On Android, it takes some time. We have had really amazing near same-day support for Lollipop and Marshmallow because Google did a long developer preview. But on Android, it's a little bit different. Usually a release comes out, it's very slow. Marshmallow has been out for a few months now, is at 0.5% of the market. So you have some time. However, we have all of the great support libraries and Google Play services available to you near immediately when they're released. But you know, it's not just about phones and tablets. It's about where else can we take our C# and .NET code and all this great code and the code behind that's shared. Well, we have full support for everything that you would expect: Apple Watch, Google Glass, Android Wear, all the Amazon devices such as the Fire TV. So you now take your C# and .NET code to all of these great new platforms. Now to get started, we have two great IDEs to get you started, so where you can do development. Microsoft's Visual Studio, we have full support when you install Xamarin, as the Xamarin plugin gets installed, to do all of your iOS and Android development. If you're on Visual Studio on a PC, we support 2012, 2013, and 2015, including the community editions that are from Microsoft. Now, if you don't have a PC or you don't have Visual Studio, no worries. We have our own amazing IDE. It's called Xamarin Studio. It's available on both Mac and PC to do iOS and Android development. And it's built and optimized for mobile development, so it deeply integrates into the SDKs and the designers to get you off the ground running, which is really great. I like to put these on the same slide because the nice thing about the IDEs is that the same solutions and same projects open in either of them. So no matter where you're at, or in a distributed team, maybe some of your developers are using Visual Studio, some Xamarin Studio, same solutions, same projects will open and everything will merge nicely. Now, if you're installing Visual Studio 2015 for the first time or upgrading, I wanted to point out that you can just install Xamarin during that installation step, and we'll take care of everything for you. Just select Custom, and then under Cross-Platform Mobile Development, select Xamarin. Now, if you haven't gotten started yet or installed Xamarin, just head to xamarin.com/download, where you'll register and then get our full universal installer for either Mac or PC. And this will download and take care of everything you need to get ready. So truly, anything that you can do in Objective-C, Swift, or Java, you can do it in C# and Visual Studio with Xamarin, to the point that you can take any Objective-C or iOS library or Android library and create your own C# bindings around them. We'll talk about some preview technologies to help speed up that process. So let's take a look at how you would get started with Xamarin. I'm going to jump out of PowerPoint really quick. And here I'm just actually on my Mac. You can see I have an iPhone simulator and our Xamarin Android player, which is our Android emulators. And I'm just going to do a lot of my work today. We're going to see both IDEs in action. We're going to do some in Visual Studio, some in Xamarin Studio. So since I'm on a Mac, and I'm doing a Mac for iOS development, because you have to have a Mac somewhere to actually build and compile up the iOS application, I'm going to open up VMware Fusion. You could use Parallels or some other virtualization, or you could have a separate PC completely that talks to Mac. But I'm just going to open this up, and this is Windows 10, and I'm inside of Visual Studio 2015. So we want to get started today, so I'm going to select New Project. And when we do that, this will open up all the brand new project dialogues for you. And when you have Xamarin installed, you should see Android here. These are all your Android-specific templates, such as Android Wear application and OpenGL game. You have Apple Watch applications. You'll see iPad, iPhone to integrate those, or even extensions to iPad if you want to go into like Today or Share widgets, essentially. And then you're going to see cross-platform. These are all of our cross-platform templates. And we're going to focus first on the first two, these native portables, and then we'll talk about Xamarin Forms in a little bit here. So essentially this is native portable. We call it native or traditional development. And a portable class library would be used in this one. Essentially it's a class library with .NET namespaces and libraries available to you, but portable, which means you can access that code from multiple targets such as iOS, Android, or Windows. And then there's native shared, and essentially that is a shared asset project. And a shared project is like file linking. It's a little bit more advanced and complex because all of the files that are in here are kind of bundled into the application. I'm going to go ahead and select the native app, and let's call this Monkey App, and we'll just make it 3 at the end just in case I have more Monkey apps. Always create Monkey apps. So let's do that here. We'll just hit OK. Now I selected Portable Class Library, so what this is going to do is going to create our iOS, Android, our shared code project, and if I have Windows Phone SDKs installed, it'll also create the Windows Phone project for us. So we'll give it a second here just to spin up. Now what I'm going to build actually today is a real application. I thought, what could I build really quick to show not only Xamarin and Xamarin Forms. You could do a button click demo, you could just do something, see it on the screen, but let's actually build a real app. Let's put some information into a list view and get that started. And the first thing we see here is that I'm not going to use any source control for this project, but let's take a look at the structure here. Essentially what we have is a portable class library that has some of .NET available to me, and it has this thing called My Class. We have a full native Android, iOS, and Windows Phone application. If we look at Android, for instance, we have our Android libraries and the shared code from here. So any code that I'm writing in my portable class library will get bundled into here. And the same thing here. Here's my iOS project. We have Xamarin iOS and our shared code there as well. Cool. So let's actually write a little bit of code. I'm going to open up this My Class file, and we're just going to delete all this code because we don't want any of that. All right. So we need to get access, and what we're going to build today is a Monkey application where we go up to the internet, pull down some Monkey information, and then display it in a list. So let's do that. We need to get our data from somewhere, and like every good developer, I have a Monkey JSON file on my personal website. So we can do a few things here. We can take this JSON file, which is like XML type of markup, but it's JSON, JSON. And there's a few things. Essentially, this is a nice, readable way of displaying data, very familiar with RESTful services that would do this. There's a few ways to generate our C# classes. I can go to json-to-c# and hit generate, and that'll pull in my actual object here. Or if I want to, I can come into Visual Studio and say edit, paste special, and paste JSON as classes. Now it doesn't know the names or what it's going to do, so I'm just going to go ahead and delete a few things, and we're going to call this class a monkey. There we go. Now I'm going to write all my code that's shared right in this project just to make it simple. So here's what we're going to do. We're going to bring in a few namespaces in here. We're going to say using system.collections.generic, using system.collections.object model, and that should be good, just so that we have some lists of data. So let's create a public class, and we're going to call this monkeys view model. We'll kind of structure this in an MVVM type of way. So what we're going to do here is we're going to go ahead and not create that there. There we go. What we're going to do is we're going to create a public observable collection of said monkey. So it's kind of a list of monkeys. Call it monkeys. And we're just going to say get. And we can create a new observable collection of monkey. There we go. And then what we're going to do is we're going to create a public async task and call this get monkeys async. So this is a method that we're going to call to actually go up and pull down some data. So I'm going to bring in some tasks there. Lovely. So what we want to do essentially inside of here is first let's do a try catch. There we go. Exception EX. And instead of throwing, let's just do a debug.writeLine. Just output the exception, and we'll bring in that namespace with quick action, use system diagnostics. Now what we can do is we can say var, and let's create a HTTP client, new HTTP client. And HTTP client is a library, a part of .NET, that enables you to actually go out, download streams or strings of data from the internet. So here, for instance, we can just bring in that namespace. It lives in system.net HTTP. And now what we can do is we can say var JSON. So we're going to get a string from it. We'll say client.get string async, and it's going to want a URL. So we'll say http://montemagno.com/monkeys.json. There we go. And I always like to validate that I typed this correctly. I do have a long last name. There we go. Just paste that in there again. There we go. Looking good. We can close this down. All right. And then what we need to do is we need a way of deserializing this information. So to do that, we're going to use a library called json.net, which enables you to take this string and essentially convert it into our objects. So here we're going to browse our package manager. And here's newton.json. And we're going to say, let's go ahead and install this into all of our solutions. So this will go ahead and download essentially our NuGet package and run any scripts that it needs to run. There we go. Perfect. All right, I'll open it one more time. And we can close out. And then we can come up and say, using newtonsoft.json. It's just a new library that we added. So let's go ahead and get our items and say JSON convert.deserialize object. This is going to be a list of monkey that's going to come in, and we'll pass it the JSON. Oh, and I should make sure that I await on this. This is going off on a background task. So we're using async await type programming here. So there we go. And now what we can do is we can say for each var item in items, let's go ahead and add that to our monkeys. Add and item. Perfect. Now we have our shared code in place. Yeah, we can go ahead and build that up. Now we actually have the shared code. This is what we're going to use for the rest of our demos. And this is looking pretty good. This is going to go out, it'll return, it'll fill up this monkeys, and it's just very simple, one screen of data. But let's actually start implementing this here. So let's take a look at our Android application. And what we can see, it's a native Android application. We have all of our resources, our drawables, layouts, and values like you would expect from an Android application. So drawables are like your icons. Layouts are going to be an XML type markup for Android. This is what Android applications are. So when we double tap on the Android XML, that'll load our designer. And then we also have values, so we have some strings here. So let me pull out the toolbar, and we'll pull out some properties here. Make this a little bit smaller. All right. So our Android designer that Xamarin ships in is essentially a drag and drop designer, so we can kind of zoom in, zoom out. We have a hello world here that we could see. We could go to our source down at the bottom, and we could change that. We could say get monkeys. What we're going to do is whenever we click that button, we're going to load the monkeys into a list. So let's go to list view, and there's our toolbox. There's we get buttons, lists of data. There's our big list that comes in here. I could turn on some material design helper grids to kind of like let me know where this is all going to come out to. So I could come in and I could go through all the properties and say, oh, I'd like the margins here to be a little bit different. So let's make it like 12 dp. Looks pretty good. And we can see the name here of this object is going to be list view 1. All right. So that's about all all we're going to put in here. And now we need to integrate our code in the back end. So I'm going to come down over here to our main activity and open that up. We'll shove down our toolbars. And here's what we're going to do is by default it gives you a little button click code, so we're kind of good to go here, and a little int count that just increases the count. So let's do this. Let's go ahead and say monkey view model. There's our view model. So that's coming from our shared code. There's our view model. And down here after we create the view, we'll say view model equals new view model. There we go. Now, we also have to find our list. So we'll say find view by ID, and we'll get our list view back. And we'll say resource dot ID dot list view 1. Perfect. Then what we can do is we can go into this actual method whenever we click that button to say async delegate. Oops. Async delegate. There we go. And instead of just go ahead and increasing the count, let's go ahead and say button dot enabled equals false, and then button dot enabled equals true. There we go. And let's go ahead and say await view model dot get monkeys async, and that'll go out, get all of our monkeys asynchronously coming back. And then what we can do is we can fill in this data. Now I could go ahead and figure out what all the cells are going to look like. What we're going to do is we're going to say list.adapter equals a new array adapter, and we're just put out a bunch of strings into this list. So to do this, we're just going to fill in a few properties. So we'll take in the context. We'll go ahead and say android.resource.layout, and there's some built-in layouts that you can use. There's a simple list item 1, and we'll say fill in the resource.id text 1 property, and then let's bring in our good friend using system.link, so we can actually take these monkeys and turn them into a string here. So we'll say viewModel.monkeys.select, and we'll say m equals, and we're going to select a string here. There we go. And that string, we'll do a string format, and we'll say m.name, and then we'll say pop, let's say from m.location. Do some string interpolation in there, and that's looking pretty good. And then of course it needs to be an array, so we'll say toArray. Lovely. There we go. All right. Now our code's kind of good to go. I'm going to set the Android project as the startup and just compile it here. And what this is going to do just on my device, on my PC side of things, it's going to compile up my Android application and build the package up. Now, up in here, we'll see our debug options, and I could run it in a Visual Studio emulator, or I have a Nexus 4 that's running over here on my Mac, so I can go ahead and deploy there. So let's go ahead and deploy this here. Let's go ahead and package up the actual application and run it here on our Android emulator. You can plug in any Android phone into your PC and actually just start a debug process right on that device, or use any emulator from Google, Microsoft, or our very own Xamarin Android player. You can use any emulator you want. So here we go. You can say get monkeys, and there we go. All of our monkeys in a list. Lovely. All right. Let's see what else we can do here. We can come over to our iOS project and build this out too. So our iOS application's already using our shared code that we can see right here. I already brought in Newton.json, and then of course Xamarin iOS. So what I can do is I can open the main storyboard project, and just like Android had Android XML to describe its user interface, iOS uses storyboards to give you an overview or an outline of your application. And just like Android, we have a full toolbox available to you, and I'll bring out my properties too here. So this is going to power up and spin up our storyboard designer that ships part of Visual Studio. We also added support for NIB files, XIB files too, which is very nifty. So let's go ahead and bring this a little bit over. takes a little bit of time the very first time when it spins up, but it should be good to go here. And what we're going to see is kind of the generic view of an iOS application. Let's see. And there's our toolbox, and here's our generic view that we have. So you can kind of scale it, and you can use auto layout or different grids. We're going to go ahead and say this is an iPhone 5S, and that'll rescale it here. And this is a view controller, a view of our application. Not enough time to actually put in lists of data, things like that, but let's just slap down a button, put it here, and let's just maybe go in and then here's our button. Then maybe let's like put down a label, and we'll just describe the first monkey that we have in the list. So let's do this here. Now when you have the label, we also have properties in the bottom right, so I'm going to say label monkey. There we go. And this button here, if I select the button, I could say button get monkeys. And then I can change the text on it to, let's say, get. And as I change that, it updates the user interface. Now every view controller has some code behind, so when I select the view controller, we can see the class's view controller here. So if I want to add a click event to this button, I'll just double tap it, and that's going to open up our view controller in the code behind. So now we have different lifecycle events for that actual view. And it adds this touch up inside event or a click handler. So let's go in here and we'll just say monkey list view, view model. Sorry, monkey's view model, and we'll just set that equal to a new one. Then what we can do here is we can say, all right, we're inside of our list here, and we could spruce this up a little bit and mark this async. Let's go and say var, or sorry, await. And we'll say view model dot get monkeys async. That'll come back out, get our monkeys, and then what I can do is I can say label. So label monkey is what we described in our designer. And we can say text, and then we'll say let's go ahead and grab our view model dot monkeys, and we can check against null by using our null condition operator of C#6. We'll also check to make sure there's a monkey in there. And we'll just grab the name, and if any of that's null, we'll do string. We'll say no monkey. Cool. Lovely. All right, so now we could run our iOS application, set that as the startup project. And what we're going to see here is in our debug menu, we have iPhone and iPhone simulator. I'll select the iPhone simulator, and we can go ahead and add some breakpoints in here. And we can start a debug process on our iPhone simulator. Now that iPhone simulator is on my Mac, so it's actually going to launch the iPhone simulator over on my Mac. So this will build up the iOS application, and what's happening here is it's compiling locally on my PC, the C# code, and then it's essentially starting a remote debug and compilation session over on my Mac. Now, also, if I had an iPhone device plugged into my Mac, I would see a drop-down of iPhones that I had plugged in. So here's our iPhone simulator. I'll bring that into the center of the screen. There it goes. It launches the application. I'll just put it over here for good measure. And this is our beautiful splash screen of the application while it starts up the process. Let's try it one more time. Definitely got installed, so that's good. I am using quite a bit of RAM here, but here we go. We have get. We'll hit that get button. We'll hit a breakpoint here, just like you would expect. I can go into my view model. I can see there's no monkeys in the list. We'll go out, hit OK. Already it's back that fast. I could go to my view model. I have 11 monkeys inside of here. And there we go. Here's all my information. And just hit continue. And then my iPhone simulator's displaying Baboon. Perfect. So now we're reusing that logic, and I could build out my user interface. But I'm sharing all of the business logic from my portable class library, and I could do the same over on Windows Phone too. Lovely. All right, let's jump back over to some slides. So we just saw exactly how to actually start building some iOS and Android applications natively in the traditional Xamarin approach to building iOS and Android applications. However, a lot of our developers have asked us, they said, you know, it's really great that we have the ability to craft these native iOS and Android user interfaces all in Visual Studio, but it sure would be great if some of my applications that maybe look very similar between the platforms or doing a lot of data entry applications, or just some way that I could build out a shared user interface. And kind of knowing that it would be an abstraction above all of the different APIs and controls on the different platforms, because obviously not all the controls are the same between iOS, Android, and Windows. What we did, such as we listened, we said, yeah, we can do that, and we created Xamarin Forms, which is a library that sits on top of the Xamarin platform, allowing you to build native UIs for iOS, Android, and Windows from a single C# code base. You can share your code behind and get this user interface library. So how that works, this is the traditional approach that we just saw, that shared C# backend and iOS, Android, and Windows UI. We take that same shared C# backend and we enable you to bring in a shared UI code base with Xamarin Forms. But as you can see, there's still a little bit of purple, green, and blue up top because that's any platform customizations that you want to do or APIs in iOS or Android that you may want to add to your applications. Now, traditionally here in Xamarin applications, the traditional Xamarin approach, most of our developers share between 60 and 70% of code. With Xamarin Forms, I can even push it up nearly to 100% of code, somewhere in the 90% range, just based upon how much platform-specific features you want to add. Now, what's included in Xamarin Forms is quite a bit. It's not just a UI toolkit. While it does have 40+ pages, layouts, and controls that you can build from C# or from XAML, and we'll take a look at that. And XAML is an XML-based markup, and with XAML, if you're doing any XAML development, you know that data binding is very important. So we brought two-way data binding system in that allows your user interface to automatically react to the code behind without manually setting properties with just a simple markup. We also built in a cross-platform navigation system, so you can push and pop pages modally or not modally. An animation API that uses the underlying core animation or Android animation systems. A dependency service, so you can actually access those native APIs easily. And a messaging center to do pub/sub across different components of your application. Now, most applications start with pages, so these are things like content pages, master detail, navigation, or tab pages. Things that you kind of expect across the different platforms, like a flyout navigation would be your master detail, or a tabs page with tabs on the bottom or top based on platform. Then you get to actually lay down your controls in a specific way. We have a layout, essentially stack layouts, grids, relative layouts, and scroll views. You can mix and match these for your needs. And then there are the actual controls, or the views, things that we were able to abstract into a common API of Xamarin Forms. Things like labels, buttons, editors, maps, sliders, search bars, things that you would expect that are similar between all the different platforms that could be abstracted away. Now, these are Xamarin Forms controls. And what happens here is when Xamarin Forms, you use the Xamarin Forms control, you interact with that button. When it has a click event, you get that click event. But what Xamarin Forms does is if it's running on Android or it's running on iOS, it lays on the native control. So even though you're interacting with the Xamarin Forms abstraction, what your users are seeing are the native controls. We don't draw anything or anything like that. It's the native controls that Xamarin Forms lays out for you. Now, we always allow you to do custom controls. You can bring in your own custom controls or customize any of these controls. And we have an amazing ecosystem of amazing companies that have been building, all sorts of controls like, calendars and charts and grids and everything you can imagine since the Syncfusion, DevExpress, Telerik, Infragistics. They not only had Xamarin iOS and Android controls, but they brought it over to Xamarin Forms and a cross-platform API. Now, I want to show you some things that are similar and different if you're coming from the Windows side of the world. Maybe you've done WPF or Windows Phone or Windows Store applications. So some things are going to look familiar and some will look a little bit different. Essentially, it's all XAML, so it's a XAML markup, but it's our schema, so it's our controls. There's Xamarin Forms controls and properties. So you're seeing on the left-hand side things like stack panel, text box, list view, checkbox, or what you'd expect. But we've essentially mobilized them into switches, list views, entry, stack layout. But some things are the same, like label and button and image, because you can only describe a button so many ways. And when it comes to the data binding, it's nearly identical. We have advanced data binding with converters, converter parameters, string formatting. You can do two-way, one-way data binding. When you get into list views, you have item sources, item templates, data templates. And then the only thing that's different is instead of a data context, you're going to be binding to the binding context. And since it is our schema and our markup, essentially it's XAML markup but with our schema, we can do really cool things like do on-platform, which allows you to customize based on iOS or Android or Windows what your users are going to see. So this is what you kind of expect from the native UI side of things. So we may have a tabbed page, for instance, we're building a login screen. And then inside of here, we have a content page with a stack layout, 2 entries binding to a username and password, and then a login here with a command that would get pressed to actually click on that command and then call a login command. Most importantly, what we're seeing here on iOS, Android, and Windows is proper native controls for native login, native usernames, native buttons, and native tabs, because it's laying down the native controls. So you get tabs with icons and words on the bottom on iOS, just on top for Android, and a pivot control on Windows Phone. So let's take a look at that really quick. So here's what I'm going to do. I'm going to come back over into this application that we were just on. I'm going to open up this class, and we're essentially going to copy all of this data into a new Xamarin Forms application and rebuild this application in Xamarin Forms. So here's what we're going to do. I could come into here and say File, a new project, and then instead of creating a native portable traditional, I could go Xamarin Forms portable and it'll lay it out for me. We're going to take a quick look over at Xamarin Studio. So I'm going to come over to our IDE, and I'm going to open up Xamarin Studio and give you a workflow of Xamarin Forms here. So Xamarin Studio can be run on iOS or on Mac or PC. On Mac, it supports iOS, Android, and Mac development and shared code, and then on the Windows side of thing, it has Android. So we're going to say New Solution. And this is what our new template dialogues looks like. So you have iOS, Android, Mac applications. And right under here, we have cross-platform app. And we're going to see the Xamarin Forms app. So we'll say next. So we'll say Monkey app, let's call it 4, for iOS and Android. And we're going to use a portable class library. If you want to add Xamarin Insights or Xamarin Test Cloud integration, just a simple checkbox here will generate that all for you. And we'll just hit Create. All right. Now, just like we had before, we still have an iOS, Android, and a shared portable class library. And this is really important because Xamarin, we don't cross-compile or anything like that. Each iOS and Android application has its own linker and compiler and optimizer. So what we're going to see here is that I have the Xamarin Forms packages with already updates available for the latest version of 2.0 for iOS and Android. And this is where I would write platform-specific code. Now up over here, if I zoom in, we're going to see this Monkey App 4. Essentially, this is where the application starts, and this is in our shared code. What we're going to see here is that we have an app and some code that says Welcome to Xamarin Forms, and some start, stop, sleep, and resume methods. We're not really going to use much of this, and that's okay. But automatically, that's going to be brought in here to our Android application. Here's Xamarin Forms and everything that we need. And the same thing for iOS. So let's go ahead and do this. Let's go ahead and simply create and add a new file. We'll call this monkey stuff. There we go. This is in our shared code, and we're going to go ahead and paste all of that logic in there. Now it's going to get upset at me. It's going to have me resolve out some namespaces here first. So let's go ahead and bring that in. That looks good. It's going to have me bring in this. And we're first going to notice that HTTP client isn't available. And that's because with Xamarin Forms, we also enable you to target Windows Phone Silverlight. So it has all these checkboxes checked. Essentially, this is the subset of .NET available on all these different platforms. But that's okay, because we need to add some NuGet packages anyway. So I'll double-click on Packages, and we're going to add JSON.NET again. And then I'm going to come down to the Microsoft HTTP clients and automatically add our HTTP client here inside of Xamarin Studio. We didn't have to do this earlier because we weren't targeting Windows Phone Silverlight, and it was just part of that package. So here we go. We have Microsoft Net HTTP. We can go ahead and resolve out some of these namespaces now that we have those libraries. But at the same time, I'm also going to go ahead and make sure that I bring those libraries into our other projects. I like to add them into all of them, just in case there's any platform-specific implementations. So go ahead and install those. I'm going to do the same over here on iOS. Lovely. Looks like one more namespace to resolve out. Okay. We'll zoom back out here. So that's the same business logic, but what we want to do is create a user interface. So I'm going to come in and say Add New File, and we're going to come into the forms here, and we're going to create a content page XAML. We're going to call this Monkey Page. There we go. There's some code behind here. So what we could initially do is say binding context equals a new monkey view model. There we go. And what I'll do is I'll save this out too. I'll say VM. So we're going to use this in a little bit here. VM equals. We'll new all those up at the same time. Lovely. Then I'm going to come into my XAML, and here it is. We can go here, and we have our monkeys. There we go. And the first thing that we could do is we could come in, and let's create a stack layout. And we're going to give some spacing in between here. We'll say, let's give some padding on the screen equal to, let's say, so 0, 20 on top, 0, and then 0. So different padding, and we'll say spacing will be 10, for instance. That's different padding there. And then what we're going to do is let's put in some buttons. So we're going to put in a button here, and say x:\name. So we create the backing field. We'll say button get monkeys. And the text here, and this is a Xamarin Forms button, will be get monkeys. Monkeys, there we go. And then what we want to do is create a list view, a Xamarin Forms list view. So let's do that. Here's a list view. And what I'm going to first set is the item source. So it's going to be essentially what data it needs to display. We're going to use this special markup called binding to our monkeys. And if you remember, that monkeys was represented back in our monkey stuff right here. Observable, it's a public observable collection. So they'll get, Xamarin Forms will automatically get notified when objects and monkeys are added to this list. Then if I don't do anything else, it'll just call a toString on our monkey, and that's all we'll see. So we actually want to give it a nice item template. So we'll say item template. And then what we can say is, let's create a data template. So we're going to do some nice binding inside of here. There we go. And what we need to do now at this point is actually put something inside of it. You can do any custom cells that you want, or you can use some that are built in already from Xamarin Forms. So we're going to use an image cell, and we're going to set an image source. So we're actually set a little bit more in here. We'll say binding. Now this is to the monkey itself, so we're just going to say image. There we go. We're going to set the text property equal to binding name. And then I'm going to say detail. Oops, we got to do one more thing. Close that off. Detail equal binding to location. There we go. Perfect. Now, if we go back to our monkey stuff, we have an image and location and name that we're going to do the data binding to. And that image essentially is a URL out to the internet. Xamarin Forms will automatically download and cache all that data for me. Now, in our iOS and Android projects, Xamarin Forms needs to know where to go. So if we remember, we have that app here, and that had the startup page. Well, let's actually go ahead and say, well, we want a new monkey page. There we go. That's what we wanted to create, a new monkey page. That's going to be our main page of our application. And then what we'll see is in our app delegate here, in our iOS project, essentially we're going to inherit from a Xamarin Forms application. And then this is going to initialize our iOS application. And the same thing is true over here for Android. So let's go ahead and start this up. We'll just go ahead and start it up on the current emulator that we have running. It's an iPhone 5S. There we go. Let's do that. We'll go ahead and launch this application. Notice I haven't written any code inside of my iOS or Android applications. Everything is shared. So go ahead and pull up our monkey app. Oh, I need to actually do something when I click this button. Let's do that before I launch the application. So let's go back, and I could do some more data binding and create some commands that will automatically call our method. But we could say button get monkeys dot clicked, say plus equals. We'll do a little async here, and we'll say await VM dot get monkeys async. Got to do that. We can also interact with our actual button, so we could say button get monkeys dot enabled equals false, and when we're all done, button get monkeys dot is enabled equals true. Let's do that. Got to get those monkeys. All right, cool. Let's do it one more time here. So we're going to launch the application. Say get monkeys, and there we go. Monkeys with images coming through. It's just using the default image cell template that's built in. But we're seeing it all back in. I could go in and customize this and do custom cells, which is what I would probably do inside of here. There's some very cute monkeys in here. We could say get monkeys again. It's going to go get more monkeys from the list. Very nice. Now, if I run the same exact application and make the Android project the startup, we'll see Android devices in here, and we can start debugging the Android application right here on our Xamarin Android player. So this now is on my Mac compiling up this application, and then it'll start a debug session right over here on my Android app. Now we can see that right up top, Xamarin Studio is telling us exactly what's going on, and now it's installing our application. If it's the first time running an Android application, we install a shared runtime, essentially. So let's see here. This should go ahead and start it up. Deployment complete. We're getting the Android look and feel because it is an Android app. We'll say get monkeys, and there's all of our monkeys coming in with all the images downloaded. Perfect. Created monkey applications, traditional and non-traditional, right here. Now, before I jump back into slides to show you some of the cool, new, awesome features of Xamarin 4, I wanted to also talk about what this monkey application could look like. Now, I spent a little bit of time, and I have another instance of Visual Studio here, and I have this monkey application. It's a traditional application, just Android, that I built over in Visual Studio in the traditional Xamarin approach. So what we can see over here is that I have a lot of different layouts and fragments and a lot of different approaches, toolbars using the latest material design, different icons and assets that are inside of here, which are very nice. And what I wanted to show you is kind of a very finished example of what a monkey application could look like built with Xamarin. So I'm going to go here. I'm going to launch the application. Here it goes. It uses nice recycler views and grids to display all of our monkeys. We have a nice flyout navigation where I could go get profile. There's me, nice circle images. Coming back over here, I could go ahead and tap on a monkey, and then I get very nice parallaxing, all part of the Android material design. And this is the traditional Android approach here. I think probably my favorite monkey has got to be, there's a golden tamarin, Xamarin. Some math for you. This one's very cute. So I just had some fun, and I built this application in just about a day, just to pull in that data and display it in a nice Android optimized list. Lovely. Cool. All right. Let's come back over to slides really quick. So we just saw essentially building the same application in iOS and Android traditional with Xamarin Forms, and also took a look very quickly at a fully built application with Xamarin Android traditional. But let's talk about what's new in the Xamarin platform when part of coming to Xamarin 4. Essentially, we have a lot of brand new awesome stuff to enable you to build better, faster, amazing applications. We've come out with brand new versions of Xamarin Forms 2.0, enhanced a lot of integration in Visual Studio, full optimizations for iOS 9 and Android Marshmallow, and some really cool preview technologies. So let's go ahead and take a look at some of this really quick. Xamarin Forms 2.0. With Xamarin Forms, of course, we really care about deep integrations with the different platforms and making sure that your application looks great across all of them for iOS and Android. So we've designed and integrated a lot of new libraries such as AppCompat. We'll look at that. Done lots of performance optimizations across the board for not only that, for your code, but also compiled XAML. So if you're doing XAML, it'll be all compiled up for you ahead of time with lots of optimizations. Come out with some new Windows previews and some new gestures added to Xamarin Forms. So a lot has gone into Xamarin Forms 2.0. So let's start with material design and talk about that. Material design is kind of the base of how Android applications are written, whether they're in traditional, Android applications written without Xamarin or with Xamarin. And essentially, material design and material theming is an important thing to know when it comes to Android. Essentially, it makes your applications look beautiful with styling and accents across all the different devices. Now, material design was part of Lollipop, Android 5.0. And while Xamarin and Xamarin Forms always supported material design, there was a problem even in the Android community, which is that you could only show material design and theming on Android 5.0 and above devices, which is a smaller portion of the market, maybe 25%. So Google came out with this thing called the Support Library V7 AppCompat, which allows you to bring material design and theming all the way back to older versions of Android. And with Xamarin Forms 2.0, it's been fully optimized to integrate AppCompat. It's super simple with just a few lines of code, and I have a whole blog on it to do this. And it's going to give you multiple things. You get to use your accent colors and styles and theming. This is my Hanselman Forms application. You can see this is a Xamarin Forms application. I get great material tabs and a navigation drawer that pops out over top of it. You can fully customize it. And this allows you to target KitKat, Lollipop, or Marshmallow devices and give you a nice, beautiful application across all the different devices. Lovely. Let's talk about some optimizations. Obviously, we know that a lot of data, applications there are lists and lots of data that's being displayed in lists. So we made a lot of improvements overall since Xamarin Forms 1.0 to list views, but we have some cool optimizations to get you started, even enhanced. Essentially, we've introduced a new property called caching strategy. And what this does is it allows you to tell Xamarin Forms how you want it to cache and recycle your lists. So, by default, we'll use retain element, which is kind of the default. It'll generate a cell for each item. This is really, really good if you have really complex data bindings and a huge number of different bindings, and you're essentially morphing all of your cells frequently, so things are getting bigger or smaller or different sizes. You're changing the entire layouts. Because essentially, you wouldn't want to cache those things. They're so different all the time. However, you may have cells that are very similar with smaller amount of data binding inside of it. For instance, my monkey application would be great for that, or even if I had, made it a little bit more complex, would be totally fine. And we have something called recycle element. It will help reduce your memory footprint and execution speed by recycling all of the cells in the lists. So we have some great guidance about performance of the list view on the link on the bottom. These slides will all be sent out, of course, to you guys, and the recording will be sent out too, so if you don't catch it right here, it's okay. But I'll show you exactly how to add this and start it into your application. By default, it'll use retain element, but if you're creating this from C# code behind, you just pass in a caching strategy into the list view constructor, or add the caching strategy recycle element property to your list view. That's it. It's taken care of completely. But let's talk about some more optimizations, especially when it comes to XAML. Traditionally, XAML would be runtime parsed and checked. So essentially here, with a new XAML, C we call it, compiled XAML, it'll allow you to do multiple things. With XAML that's not at runtime, essentially, or if it's at runtime, you don't really get error checking of your code or your XAML, and also your XAML files need to be kind of included in the final assembly. But with compiled XAML, no longer the case. You get compile time checking of your XAML. Things will load, and instantiation time will be faster of your elements, and of course, it will help reduce your file size by a little bit too. So a lot of little optimizations. And it's super simple. You can apply it to all of your XAML files at an assembly level by adding this assembly flag, or you can pick and choose which ones you want to do on a class level. So maybe you just want to turn it on for a few views and just test it out and see the different optimizations. You can say XAML compilation attribute, and the XAML compilation options are either compile or skip. So you can even turn it off for some and on for others. And of course, we have full documentation to get you started on XAML-C. And of course, we've introduced a Windows 10 UWP preview as part of Xamarin Forms 2.0. Now, with Xamarin Forms, we always supported iOS, Android, and all the different flavors: iPhones, iPods, iPads, phones, and tablets on Android. And we always had Windows Phone 8 and 8.1 RT support and Windows RT support. But we're introducing a new Windows 10 preview for UWP applications, allow you to take your applications to even more platforms, and you can get a full getting started guide there. So let's take a look at all this brand new awesome stuff in Xamarin Forms 2.0. So here's what we're going to do. Is I'm going to go ahead and open an application that you may have seen if you were on the Xamarin 4 announcement webinar. It's called My Weather. Essentially, it goes out and it queries all of the weather for a specific location. Let's go ahead and load up our project here. Let's give it a second. It also not only grabs the current weather, but also gets a 5-day forecast. So it's a little bit more of a fully fleshed out application. So what we're going to see here is we have our portable class library with some models, services, views, things like that, our view models for our weather view model. I have a weather service here that's going to go out. It's going to use Open Weather Map to actually query some data. And it's very similar. We are able to use our HTTP client to go grab a string asynchronously and deserialize our weather that's coming back from us, which is very cool. And then we have a few views that are displayed. So here's our weather view that we see here. And it has an entry field with location, temperature, and condition, and a button that says Get Weather. So this is our Get Weather command. And then we also have a forecast view that's over here. And this is a list view, but it's been really optimized for Xamarin Forms 2.0. The first thing that we're going to see is that I've added the caching strategy into my list view, so it'll cache all of the cells automatically. But I also went ahead and I added a new feature also, which is pull to refresh. So on the list view, you can automatically pull down and get a refresh view. So I simply set is pull to refresh enabled to true. I tell it to, hey, call the get weather command. And then I have this is refreshing set to is busy, which is a property I set. And we can take a look at that really quick. So let's go over to our weather view model. Here we go. Our weather view model is a representation of what will be seen. So the core of Xamarin Forms applications is often iNotify property change, which is a way of updating things in the code behind that will propagate up to the user interface. So here, if I change location, I call onPropertyChanged, which will essentially go down here and we'll say onPropertyChanged and invoke an event that Xamarin Forms will be listening to. We have some other things in here, such as imperial, temperature, condition, and the forecast here. And here's our execute get weather command. And what we're going to see here essentially is that I go out and I say weather root, get the weather service, get the weather, get the forecast, and then I data bind up some of these elements, so temperature and condition. So if I take a look at that here, that condition, it goes out, it calls on property change, which will tell Xamarin Forms to go and update the temp and condition in our view. So if we look here at our weather view, here it is. Like these are the temp and conditions, kind of similar to the data binding that we were doing previously. So let's just go ahead and run this really quick. I'm just going to go ahead and run this over here on Android, for instance. And the webinar is going to go a little bit long because I want to show you some of these really cool features, so definitely stick around. We'll take a few questions too. So let's go ahead and I want to add and extend this application just a little bit. So let's go ahead and take up my application and we'll get it started here. Let's go ahead and see it launch it here. Good old compilation time. Sometimes it's a little bit bigger of an application, so let's go ahead and start it up and probably install some stuff for me. Let's take a look at the output. Perfect. All right. Let's give it a few more seconds here to compile up and start the process. There we go. Perfect. So I've also integrated in the application compat stuff in here too. So we have a full list view or table, or sorry, tabs, material tabs that are going back and forth. I can say get weather. So go out, it's 49 degrees and it's definitely raining here in Seattle. If I go over to forecast, all my cells are automatically being recycled for me. If I pull down from the top, I get the nice pull to refresh that's going on there. And I go ahead and refresh that data. And as we can see, it's going to be rainy, 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 clouds, clouds. Oh, clear. At night, of course. Perfect. Lovely. Of course, now I could obviously not only run this on iOS, but I could also take this over to Windows 10 and set that as my startup project, which is pretty cool. And we can go ahead and run that on our local machine. And this is going to actually run in a Windows 10 universal app. So previously, we saw just iOS and Android were created in Xamarin Studio, and Windows Phone would be created over traditionally with that template. You can just add UWP in there. So we'll say get weather, goes out, gets the weather for Seattle, and I can check the forecast. There we go. Really cool. All right. What else can we do into this application? Well, maybe what we want to do inside of here, go into our weather view model, is let's say we add a new property, and maybe we want to use the GPS. So we can come in and say bool use GPS, say public bool use GPS, and we'll say get return use GPS. Then I can say set, and I'll just do a simple use GPS equals the value passed in. And then I'll say on property changed, and there we go. So maybe I want to use the GPS and put some platform-specific features in here. So how do we actually access that in our user interface, and how would we actually get this down? So I could come into my weather view model, and let's extend this just a little bit. Let's come in, and the first thing that we'll do is we'll say stack layout, and inside of here, I'm going to add some properties under here. We want to add a little switch that will data bind to that new property that we made. We're going to make the orientation here horizontal. Then we're going to make the spacing here 10. And inside of it, first we're going to do is add a label. And that label text will be, use GPS, let our users know. We're going to set the vertical text alignment to center, so it centers right in between our switch. And we'll set the horizontal options to end and expand, which essentially will make our label push all the way to the right-hand side. So it's the end, and since we're in a horizontal, it'll be the end of it. Then we're going to go ahead and add a switch in here, and we'll say is toggled, and we'll do a binding here to use GPS. Lovely. All right, so how do we want to access this GPS now that we've just said use GPS? Well, what we can do essentially is I could write an interface to say get GPS, go and write iOS, Android, and UWP code to actually get the GPS of the different platforms. And then our weather service here not only takes in a city, but it takes in a latitude and longitude. So we can then pass that into our get weather and use a different forecast in there. However, that'd be quite a little bit of code to write in the last few minutes of the webinar. So what we want to essentially do is I'm going to head over, we'll open up Edge here to go to xamarin.com/plugins. And essentially, plugins for Xamarin are special NuGet packages that help accelerate your mobile development. Things like contacts, geolocation, settings, permissions, connectivity, all are abstracted into a common API, and even the file system. And we can say get started with plugins. And that's going to take us over to a GitHub page with a hand-created list of all of our plugins. So let's see if we can find one. And here's our geolocator plugin. Things like local notifications, media, messaging, they're all here, which is nice. You can see that it's just a NuGet package. We can see right here the GitHub page associated with it. This developer looks pretty trustworthy. We can take a look at him really quickly. And that's me, adorable. And here's all the different repos, and I'm very active contributing to plugins. Plugins are made by the community, by developers like me and you, contributing to this awesome open source community. So you can actually dive through all the code. So here I could actually go in and look at the specific geolocator. I could look at the Android code that's going in here and all the different implementation, all the code that I wouldn't have to write. That's pretty nifty. And if we look at the NuGet package, it essentially says, hey, use this line of code right here. So let's go ahead and copy that. Now we need to go ahead and add these NuGet packages in. So I've done that ahead of time. I went into our NuGet package manager. And if I take a look at installed, we're going to see Xamarin Forms, we're going to see JSON.NET, and all the stuff that we would expect. But I've also added some settings plugins, text-to-speech, and geolocator, and we can see the latest version is there, so that's pretty nifty. So let's do this. Let's go to our view model, and here, let's go down here to where we press that button. And we can say if use GPS, let's paste in some code. There we go. There we go. And what we're going to do is say get our current geolocator, and then get the position asynchronously over 10 seconds and return that back as position. And then we can say that the weather route equals await weather service dot get weather, and this time we'll pass in the position dot latitude, position dot longitude, and the units. There we go, perfect. Else, if we don't want to use the GPS, let's get it the old traditional way. Cool. So let's check this out on Android. So here we go again. We'll go ahead and run this up again. So now compile up the application and launch it again, but with all of our new code, and it'll launch a lot faster the second time. There we go. There we go. We can first come in and we can say, all right, let's see how my home city of Cleveland is doing. Lovely, and we'll say get weather. We've even output Cleveland, so you can see what it is. It's hazy in Cleveland. I can use GPS in here. Now, it's not going to say Seattle because we have it set here in our Xamarin Android player to use San Francisco, where Xamarin's headquarters. So we'll say use GPS and get weather. It goes out, grabs the current weather in San Francisco. If I ran the same logic over here on iOS or Android, set that as my startup project, we're going to see the same thing work. Here, this is now going to set it as my launch application. I could say use GPS, and this should say Seattle because it uses where I'm at, so there's a current weather in Seattle. Let's go ahead and try iOS. We'll set the iOS as the startup, and let's actually go ahead and start it up here. So what we're seeing from one code base is an iOS, Android, and a Windows 10 application using geolocation, and you can use more plugins such as settings and a whole lot more, but all being optimized with Xamarin Forms 2.0, the list view, the pull to refresh, everything that you'd expect from a great native application. So here we go. This is launching. I can say get use GPS. So we want to use the current location. Now I do know there's some odd issues sometimes with the device. Let's go in here, location, and set it to Apple again. There we go. Now we're in Cupertino, and there we go. We have our weather once you set the location to where it needs to be. We can go look at our forecast, and you get pull to refresh inside of there as well. Perfect. But it looks and feels like an iOS application because it is an iOS application with tabs on the bottom. Very lovely. So let me go over really quick before we take some questions some of the other new features of Xamarin 4. So we've made huge improvements around Visual Studio integration for iOS and Android development. Essentially, as you saw here, I'm connecting over to my Mac to do the remote debug and compilations and run the simulators around a device. We've built that connection from the ground up. It's super simple to get set up with a resilient connection against any type of network. So no matter where you're working, it's just going to connect automatically at multiple instances of Visual Studio. Just go ahead and connect and you're good to go. And it's very simple. Everything is over a secure SSH connection to your Mac. And this is the dialog box that pops up. You enter your Mac's username and password, and boom, you're connected and good to go. We've also made lots of enhancements around iOS and Android. You've already seen some with Xamarin Forms and the integrations into the SDKs. But part of the designer side of things, we've essentially built a lot of the iOS and Android designers, and we've built them, and we've done tons of optimizations. The iOS is faster, initialization, faster designer service, higher DPI if you're on Retina displays. Full support for obviously storyboards, but also Zib and Zib splash screens. On the Android side of things, faster design services, and also we've added some really cool material design helpers that you saw for not only helping layout controls, but also doing material theming. We do have some really cool preview technologies that you should take a look at. The Xamarin Profiler for iOS and Android can help you detect memory leaks and different things. Maybe you're leaking events in your application or bitmap performance. You can go to xamarin.com/profiler for that. Objective Sharpie is one of those tools I was mentioning earlier about creating your own bindings. You can create a binding project inside of Xamarin Studio or Visual Studio, and Objective Sharpie is a tool to help generate that project for iOS. What's really new with the latest version of Objective Sharpie is CocoaPod integration. CocoaPod is kind of like NuGet for iOS, specifically with the different iOS archive libraries. But essentially, you can go in and you can point in a CocoaPod, download it, and generate your project. And of course, the Xamarin Inspector. In Xamarin Inspector, we demoed on the Xamarin 4 webinar, but it allows you to do live inspecting and modification of your application without having to stop debug over and over again. You can get started today at Xamarin.com. You download the Xamarin platform in Visual Studio or Xamarin Studio and get you set. If you want to get your free 30-day trial of Xamarin University, head over to Xamarin.com/university, where you can take a few of the courses for free. We also, on Xamarin University, posted tons of lightning lectures, which are shorter, like 10 to 15-minute videos on all the features of Xamarin 4. And I hope to see each and every single one of you at our Xamarin Evolve 2016 conference coming up in April in Orlando, Florida. It is by far the best development conference that I've ever been to in my entire life, and the last one. And I go to about 50 of them a year. I love it. Head to evolve.xamarin.com. And I also wanted to tell you about a quick contest, so take a snapshot of your screen really quick, where you can win a copy of Charles Petzold's book, creating mobile apps with Xamarin Forms. We're giving 50 copies away each and every single day, and you have a chance to win a signed copy by Charles Petzold himself. And all you got to do is tweet to win. Head over to blog.xamarin.com, and you'll see the contest right at the top. That contest ends on December 14th, so make sure you start tweeting right now today. I've added some resources, and these slides will be sent out to you to learn more about what we saw today with Xamarin 4, the weather application that you can download from my GitHub page, and of course plugins for Xamarin.